I'll speak also shortly about the report which was submitted to you as a foundation article and for reading and also for commentary and insight. When we applied for the funding in NSF, one of the part of that was that we said that we will not only write the workshop, we will also do some sort of review of the current practice in industry to identify some of the challenges. And also understand some of the, and do some sort of literature review where the field is and look at some gaps between those things. So we wrote, based on that, went to the field, we did some interviews and field study, about 30 people, leading people in the field. We talked with them, and we also did a fairly extensive literature review, which you can find from the report. I'm sorry it's so long, but the topic is complex. And I'll just go through some of the issues which we found out or what to discuss. I think that the classical view of requirements has emerged from this type of pushing up the task domain in which software should deal with. So the idea was that if there was something wrong in the implementation operation, it was because of the prior problems in the prior task domain. Either in the design, software crisis in '68 was applied to the structured programming, then we moved to structured analysis. That was a design problem, and in late '80s, early '90s, it moved to the sort of requirements. That was the real challenge. So the responsibility of the failures have been moved up, and at the same time, the idea has been that whenever you make progress, it is the closer you come to the machine, that's where you make progress. And that's much of the ideas behind the classical life cycle models and so forth, how this whole thing has been framed. And there are some reasons why this makes sense, especially if you look at how you manage projects and how you do budget estimation and so forth. But if you take another view of the whole ecology of software in its environment, this is probably too limited view on understanding how to manage requirements. I think one of the issues which we face here is that this issue is far from resolved. You can see a lot of comments in the practice literature that there's still a lot of requirements messes. Large number of failures, actually the failure rates have not come down. It's normally attributed to the problems in requirements. And also there are many claims which say that the economics of design efforts favor attention to the early phases, like Beam's classical study, and nobody has even questioned those things. At the same time, as I pointed out, we have seen new issues in software development. We have a shifting area of focus, very different types of systems, inter-organizational complex systems, embedded systems with many layers of things in new domains like cars, telephones, and so forth. And we have new types of ways of integrating architects in software. For example, how middleware providers are currently positioning themselves, moving from the systems platforms actually to application platforms. Then we have global sourcing and new forms of development, which is very different from the past. We have the rise of architecture standards and regulations, which influence largely the way in which we manage requirements and also the whole design process. And one aspect which actually becomes very clear when we talk with the people in the industry is the speed. That the speed at which you have to deliver software is very different, which changes the whole equation and dynamics of the process. At the same time, if you look at from the viewpoint of the disciplinary approaches to understand this phenomenon, we can see, just looking at it, that there are multiple disciplines, as I pointed out, which deal with this area. And we have, as a result, we have a wide range of terms employed to characterize these features and phenomena. I don't think that we will get away from this terminology mess. It's just going to prevail, and there's no way to overcome it. Another aspect of that is that we have very different disciplines which focus on different aspects of this phenomenon. You can clearly see distinction between discovery and then specification and modeling communities versus validation and verification communities. And there's some work, but not much on negotiation. And these are largely separate communities and intellectual lines of inquiry. As a part of the study, we also summarized what is the current leading edge practice in the field. And actually one thing which I will point out is that if you look at the requirements or the ideas or visions people set up in like late 70s, early 80s, how you should develop and design software, much of those visions have been implemented and realized. There's not, I don't think that the gap is that large. There are some differences, but largely the practice which was envisioned at that point in time is pretty much the practice we currently develop in leading edge companies to software. So common practices are that you use tools, some types of tools to manage the designs and specifications. You actually carry out risk mitigation. You try to integrate and involve different stakeholders. You do careful data and process modeling. You try to manage, at least in principle, people realize that you have to do manage traces. You try to improve over time your delivery capabilities by focusing on process improvement. You are aware of the contextual features of the design and requirements so that you do differently in different project contexts. So there are some ways in which you manage differently the way in which you deliver the software. We also found out that there's a very limited focus on stakeholder conflict, although in some of the academic literature this is much more emphasized than in practice. If you look at the way in which requirements are managed and found out, largely through focus groups and interviews. Very old technique, but still mainly used. There's an ongoing work of simultaneous elicitation and validation. They're not separate. They go together, actually, in practice. And what is also interesting is that largely the responsibility of the requirements, the quality and the content of that requirements have been shifted towards business functions or business processes. So normally, people from the business process side, process managers or account managers are the ones who actually state and manage and state what the requirements are and decide on those. Specifications use case tools or document those requirements in case tools. If there's one single technique which is widely used for requirements capture, that's use cases in its 1,000 different incarnations. And people also use natural language data and process modeling representation in some sort of hotspot mixture. But there's no single unified way of how people do that. Yes?
For the things which have been adopted and you're now implementing in current practice, who was responsible for getting to that state? Was it the researchers who thought up these great ideas and industry said, oh, that's a good idea, let's try that? Or did industry folks come up with them on their own and researchers happened to reinvent the wheel?
I think it's probably closer to the latter one. But it's much more complex chain of how the knowledge actually is adopted and transformed. And I think that very critical role is played by consultant firms, large consultant firms, large system integrators in standardizing practices and establishing what is regarded as the best practice in industry. And that's one of the things which actually hasn't been studied very much, how this knowledge actually is transformed and maintained and how it evolves over time. But that's our insight. Like in many cases, people said that they were adopting certain methods or methodologies based on their collaboration with either outsourcing software houses or with some system integrators. There was fairly little use of formal verification practices, a widespread of use of prototypes and group walkthrough sessions, even with the practitioners. And the common expectation is a formal stakeholder sign-off. It's like a contract, basically, that at some point of time you come with a contractor agreement. And people may use fairly crude measures. For example, if you have 2,000 requirements, people say that we have money only to implement 1,200 requirements. So the users go and scrap off 800. They don't care what, but at the end you expect that there must be 1,200 requirements stated. So as I pointed out, I think that many of the research ideas which were prevalent in the 80s have been covered out. The practice currently is largely based on some types of modeling techniques. People are aware of and try to manage risk. There's a certain understanding of business focus, and there's an understanding that this involves negotiations. But in one sense, the people felt that this is not enough. The environment is much more complex and it's much more challenging what we can do with these types of practices. And one thing which we came up with is that there were, after some analysis, we came up with 9 themes which seem to be capturing some of the changing environment which we are observing here. And these are some of the themes which we're going to discuss. And I'll just go through shortly over them. The first one is that instead of thinking systems as a separate software system, there's much more interest and focus in thinking about the whole design endeavor as a socio-technical intervention. And the idea is that you have to define the software as a part of the process chains or some type of product chains or whatever. It is only on one part of that larger design task. Which of course makes the environment much more complex and the language and vocabulary needed to understand this whole issue much more demanding. The other one was that traditionally the way in which software systems especially have been developed is that you come and find the stakeholders, find their requirements, and build a separate application. Now what you can see is that most of the work which is done, maybe about 80%, is actually integrating existing applications and providing new functionality or enabling new types of integration between different platforms, which is a very different environment because you don't start with the greenfield requirements. The third one is that from the user's point of view, this is regarded more like an idea of system transparency. You don't anymore actually expect that the users understand one single application, or you design for user one single application. What you are trying to do is to provide an environment for using certain type of computational capabilities. And you have to actually conceal separate applications, and you have to unify all these applications at the user interface. So seamless user experience is very important. This is to the level that people say that, for example, there's no time for training anymore. Systems must be as easy that users can just pick it up and start using it. The fourth one is the rise of the architecture and the rise of the power and criticality of the architecture. So architectural requirements have taken much central role in driving product and application requirements as a way of testing the validity of the requirements and also testing to what extent you can satisfy certain requirements. And architectural groups in many corporations actually exercise a fairly large amount of power, because they can say what sort of requirements can be satisfied, what sort of requirements cannot be satisfied. One part of that is that architectures are critical in building and implementing COTS-based software, either component-based software or off-the-shelf, commerce off-the-shelf software. So there's a duality between the rise of the architecture and the use of ready-made components in software in different levels. And that has also led to the situation where many of the requirements are not actually designed and derived by the users themselves. They are actually discovered by the vendors by anticipating the markets and the environments in which they might be using those software components. One outcome of that is also that the requirements are becoming, which was also noted in many of the papers submitted here, are becoming much more distributed. So they are distributed across many different diverse stakeholders, different organizations, and geographically and globally. So the management and sourcing of requirements is much more complex and challenging than before. And they may be related to different parts of the value chain in which the software is actually delivered. And the way in which these different components interact is much more complex than before. One outcome of that is also that the understanding of the way in which requirements are managed and how they relate to the actual final product is changing, so that you don't have a flat view of the requirements, so that each requirement is in a similar status or level. That organizations need some means by which they can layer requirements to critical, essential, not so essential, and also in terms of time frame. Which ones are critical for 1 year, which ones are critical for 5 years down the road, and on which parts of this system or components they relate to. If there's one single thing which came out of actually from the interviews, it didn't matter with whom we talked about, they said that everybody said that complexity has risen during the last 5 to 10 years significantly. And I think that what we are grappling here, which is very important to understand, is that software has always been very complex. And we have one of the people here who wrote the first famous articles about the complexity of the software and the challenges of it. And I think that this has been always the case in our field. But there was also a sense that there's something new emerging here, that many of the complexity issues which deal with I would say at the complexity at the code level has been transferred to a much more, larger environment and much more complex set of dependencies between software components, and the environmental chains. And I think that we don't currently have good means by which we can understand this level of complexity and manage it. Like the abstraction mechanisms and other things which were developed to understand and manage complexity at the software code level are not adequate alone to address this complexity. And the last point was that people also understand now clearly that requirements are not something which is sort of carved into stone and they are not fixed. That no matter what you derive now, it will change when you are actually implementing system. And you have to prepare for that evolution when you actually state the requirements. So you have this type of idea of meta requirements, that the requirements have to be adaptable over time. And how do you interweave that into your both the process and also in the product is a major challenge. And that affects both the processes and processes. So if we can put it into some type of short statement, I'm sorry I couldn't get it shorter statements, is that what the key themes are, or emerging from the interviews, is that that the business process and user process currently, or product in an environment, currently acts as a source of requirements where an increased demand is for transparency across different systems or components, and which guide requirements as to integrate separate systems or components. These different levels of architectures which have been adopted are have a prominent role in guiding requirements processes and the focus of design and implementation. And much of that is normally based on package, commercial off-the-shelf, or software components of different sorts. As a result, the processes are distributed widely within organizations, across organizations, and geographically. And they result in layered requirements across multiple dimensions. What those dimensions are varies depending on the situations. And this constant change in the requirements and in the environment generate increased complexity in managing interdependencies across requirements, systems, business processes, and technology platforms. And as a result, the designs, what you generate from these requirements, are increasingly fluid as they continue to evolve in the actually increasing speed. And this emphasizes requirements processes that can accommodate continued evolution over longer periods of time. So if you want to put it together, what these themes reflect is this type of view of the environment in which we are managing and trying to grapple with these requirements. What we did also, we tried to look at the requirements from the two angles, these 9 themes, and some emergent properties. So in a way, we took this metaphor of the cart of gates from Janus, from one of the Roman gods, which had 2 phases. And here the phases could be thought of as the one phase facing the users, or the user process or business process, and the other phase facing the design and implementation platforms and design context in which you're actually trying to accommodate those requirements. So you can see that business process focus and system transparency clearly are user-related, business process-related changes in the requirements, whereas packaged software and importance of architecture is the sort of design context which is changing. And these together drive this context in which you actually manage the requirements, so they become much more distributed, where the integration is much more significant in managing these requirements, and you have to also focus much more on layering those requirements. And these processes together then generate these emergent qualities of the whole system, which we can see the fluidity and interdependent increased complexity. That's sort of one way trying to make sense of how these 9 themes relate to one another. Of course, you can do, I will not go through that, you can start doing much more complex interactions. I think one of the issues which we want to point out here is that I don't think it's a single element alone which is important. It's probably the complex interactions between all these themes which are making this new environment so challenging and important. One thing which we did, and I will not go through this, is that how we can actually try to also understand and set up some sort of requirements. What we should be doing is to think about each of these 9 themes and think about the traditional tasks of requirements, like how should you do different discovery and elicitation, given, for example, that you have integration focus versus traditional single application focus. How should you manage differently discovery if you have a very large interdependent complexity? How should you do differently validation and verification in this type of environment? These are the types of things which we can sort of think of pulling up some type of research agenda and issues which will shape the field for the next 5 to 10 years. So if I try to put this all together, many of the original goals in software engineering IS communities have been achieved. I pointed already that out. But still, the whole problem in itself has not been solved. And I don't think that it's totally solvable at the end. But we have to understand that progress has to be made in addressing the type of requirements challenges which we are currently facing, which are very different from 20 years ago. We have new features, very different use of economies of scale and scope in scoping and sourcing software components and requirements. So this is sort of economic issue which is emerging. There's a preference to match software and design requirements instead of implementing them. So there's a matching problem much more. There's also a different level of actually using models, which was very important. The traditional idea is that we use and elicit requirements, then we model them. So we move from natural language to models. In much of the practice, what they said that they use the models to generate the requirements with the managers. So they use the models to generate scenarios of business processes, what you can do with this type of software capability. And that can be derived from the models. So what are the challenges for the discussion of the workshop? I think that these are just one of the few which became up. One of them is the nature and the means of harnessing complexity, and what this new complexity means. What is the appropriate granularity of the requirements engineering tasks and scoping at different levels? What we have to be addressing. If we have to integrate, and we are more and more facing integration tasks, that implies that we have heterogeneous model and higher levels of heterogeneity. How do we integrate and analyze heterogeneous models, new types of models? There were some actually proposals in the articles submitted here which discussed some of those issues. I think we have new types of economics, and we should not forget the importance of economics here. For example, different requirements errors may have very different economic impacts, which invalidate some of the Beam's claims. For example, if you have a COTS software, much of the COTS software may have a fairly high quality, but you may have certain requirements which you cannot implement with this COTS software, and that has a very significant economic impact. So you have to understand in a very different way the way in which the economics operate here. The practice in itself doesn't seem to be applying new ways of discovering requirements. For example, there wasn't very much talk with how to be innovative, although there's a push towards IS functions in organizations to be more and more innovative. But if you look at the techniques which we are using, they are not very innovative and generate innovation. And we don't have very many techniques which really lead to understanding deeply user tasks or model-driven requirements discovery, how you actually do that. Then we have the issue of impacts of requirements teams on process organization, project management, and development practices, which are much more distributed and much more complex than before. And there are much more intense feedback loops between different stages. And I think that one of the issues which also emerges here is that because of the business focus on the sort of user experience and so forth, we have to be much more carefully integrating what we are doing with the organizational design theory and practice, industrial design principles, and also economics which deal with business architectures and platforms. These are the coming critical issues in managing requirements for the next 10 years. So that's pretty much what I had to say, and if you have some questions and comments before we move to the Fred Brooks talk, you're free to ask or comment.
I see several people sort of looking closely at the slides too.
Yes.
I'll make sure we get some larger printouts of the slides.
Yes, we didn't meet the requirements of
They're designed for young eyes.
Yes. Yes, we didn't take into account the context of use. Any questions or comments? I think we will have a lot of time to discuss this.
We'll have a lot of time to discuss.
Yes.
I'd like to just emphasize two things that jump out at me as I
Yes.
listen to this. One of them is that and they're kind of connected, I guess, but historically, at least, I've thought about architecture as essentially a coordination mechanism for distributed design. In my interaction with executives now, I hear more and more executives talking about architecture as an appropriation mechanism. So they're thinking at a business level, they're thinking about where, in fact, are they putting in place their business architectural control, where's their cash register? So we did a DSM analysis. We were going over the results with an executive in the room, and the designers were upset because there was a module that had a lot of interdependency. It hadn't been structured properly. But the executive was very excited because he said, that's the module I want to own. Everything else we'll make open, right? So he was thinking about where he was going to control, from an economic point of view, and appropriate value. The designers were thinking about how they were going to coordinate interactions of actors. So I thought that was interesting, and I think that overlays with the economics where the complementary network effects kind of argument of economics is dominating the logic in almost all the business cases that I see today, which I think is a very different logic. So when you put economics at the economic impacts, the new types of economics, it's not just different requirement errors, it's really a different business model that's being driven by a different economic argument. Not completely different economic argument, but certainly it's much more in the foreground of discussions of requirements that I'm hearing. So I just emphasize those two ideas.